we are going to be working on 7.5, which is linear inequalities. We will be able to graph linear inequalities and write and use linear inequalities in real-world situations. In prior chapters, you have been given an inequality, which an inequality involves these four signs: greater than, less than, greater than, equal to, less than, greater than, equal to, less than, equal to. So, what you have been previously done is we knew this was our mark that we'd put it. Here we have an open circle, and the reason it was an open circle is because this was not equal to, meaning 1 was not a solution to this problem. And then we tested a point. So we had typically test 0. 0 less than 1, yes, 0 is less than 1, so we had graphed. So that is stating any of these numbers on this line are solutions to this problem. So once again, 0 was not included. If it would have been included, we would have circled it in. Now, we're going to roll same concepts over and graphing them on coordinate planes. So where does x equal 1? Well, x equals 1 right here. And it is going to be a dashed line, because same as over here, 1 was not a solution. These order pairs that are on this line are not solutions, so they cannot be included. So we put a dash line to show that this is not included. Later on, when we work with equal to or greater than, less than, equal, greater than or less than, greater than, equal to, or less than and equal to, we will use a solid line to represent. So how do we know which way to shade is going to be the next question. And this is a lot of information. It feels like we've almost skipped some stuff, but this is kind of the meat and potatoes, and we're going to then practice some here when we're done. Here we have graphed or shaded in. You can kind of see the light pink shaded in this direction. And here's the same as over here where we had 1 as my test point. I'm going to test 0, 0. So here we don't even have y's in my planes, but I'm going to plug in if x is 0, once again, and we're going to use 0, 0 later on. And this is the point I always use. Unless my line is going through this, then I have to pick a different point. Same as over here, if my line would have been, my point would have been at 0, I would have to pick either 1 or -1. You could either pick 1 or -1 once again if your line was going through here 0. So checking, is 0 less than 1? Well, yes, 0 is less than 1, so that means this point right here is a solution to this inequality. So then we would shade in this side of our line. This is kind of the same thing concept of talking about this whole a dashed line versus a solid line. And here you can see we have an equal to, where over here we do not. And this is where I'm once again stating that these order pairs that are along on this line are solutions to this inequality. So because they are solutions, they have to be included. So then it's a solid line, where over here, these order pairs that are along this line are not solutions, so they cannot be included. So that is why the dashed line is used. To check the order pair, to see which side of the graph we're going to shade in, because the first thing you're going to do is graph it and then decide which way to shade, is you're going to plug in. And I would recommend using 0, 0 as my point. So is 0 greater than or equal to 0 plus 1? So 0 plus 1 is 1. Is 0 greater than 1? No, it's not. So we are going to shade in this side, where over here my checkpoint would be 0, 0. So is 0 less than equal to negative 2 times 0 plus 4? Negative 2 times 0 is 0. 0 plus 4 is 4. Is 0 less than or equal to 4? Yes, 0 is less than or equal to 4, so we shade this way. So here's our first example. First thing we're going to do is make it seem like it's an equal to. Okay, you guys know how to graph these. This is my y-intercept, and negative 2 over 1 is going to equal my slope. You can graph that on my graph, so we have it crosses at 1, and my slope is down 2 over 1, down 2 over 1, down 2 over 1. We can go up 2, but then to the left 1, up 2, left 1. I created these dots and created this line. Now, going back, if these points along this line do not make the equation true, so if you would have picked one of those, for example, 1, 0, 1, plugged in 0, 1, 1 is 1, greater than or equal to negative 2 times 0 plus 1, well, this would give you 0. 0 plus 1 is 1. Is 1 bigger than 1? No, 1 is equal to 1. So these are not solutions along the line. The shortcut, instead of plugging these numbers back into your equation to see if the numbers, the order pairs on the line work, is realizing this does not have that equal to sign, so we cannot include these numbers. So this does not have the equal to, so it would be the dashed line, which we talked about earlier. Now we got to figure out which side to shade. So I am going to recommend shading or checking point 0, 0. So 0, 0 is my check. Is 0 greater than or equal to negative 2 times 0 plus 1? Is 0 bigger than 1? No, it is not. So we are going to shade the other. Here's another one. This they do not give us in the y equals mx plus b form. So the first thing we're going to have to do is solve for y. So same concept, draw a line to the equal sign. We're going to subtract 4x, and then we get negative 3y to negative 4x plus 9, divide by negative 3, divide by negative 3. Y is greater than equal to 4/3 x plus a negative 3. They're going to show you these steps. Now, one piece that I forgot to mention here, my sign is y is greater than equal to. Now my sign switched. Does anybody remember why the sign switched? The sign switched because I divided here by a negative. Anytime you divide by a negative, you do need to flip that sign around. So we have y is less than equal to 4/3 x minus 3. First thing we're going to do is make it seem like it's that equal sign so we can graph. We know this is going to be my y-intercept, and my slope is 4/3. So let's graph it. Over here we will, graph negative 3 at my y-intercept, and I'm going to go up 4, 1, 2, 3, 4, over 3, 1, 2, 3. I am deciding whether or not this line is solid or dashed, and it's going to be solid because it's an equal to. These order pairs are included in the solution because it's equal to, so it is a solid line. My next is figuring out which way it shades. Check the point 0, 0. We can plug in 0 here. 4 times 0 is 0. 0 minus 3. Negative 3 is greater than equal to 0. No. 0 is bigger than negative 3, so 0 is not a solution. So that means everything on this side of my solid line is a solution. Here is another example, more of a real-world situation. So pulling out the important information from the problem you just read. We know 2 times S, which is the number of rolls of streamers, plus 6 times the number of tablecloths, is got to be greater than or equal to, less than or equal to $24. That is my total budget. So take it. This is my equation. Okay, and we can graph it. The first thing we're going to want to do, and I guess it talks about here, is graphs only in quadrant 1. Because you can't have a negative amount of tablecloths or a negative amount of streamers, you're going to only be in quadrant 1. So understanding that piece. Here they actually plugged in your zeros for each. So 6 times 0 is 0. 2 times S, 24. They divided by 2. And they got S to equal 12. So 12 zeros, their first order pair. Then now they made S 0. 2 times 0 is 0, plus 6t divided by 6, divided by 6 now. 24 divided by 6 is 4. So they found the intercepts. The other way you could do it is 2s plus 6t, and this is how most of you in the class like to do it, is solving. So minus 2s, 6t is less than equal to negative 2s plus 24 divided by 6. T is less than equal to negative 1/3 s plus 4. And this is the same concept as t being my y and s being my x. So y-intercepts here at 4. My slope is down 1 over 3. Down 1, 1, 2, 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 3. Here's the line. So now I need to decide whether or not my line needs to be a dashed or a solid line. Because I'm including it with my less than equal to sign here, it needs to be a solid line. Now, I gotta decide which way graph. Alright? Test 0, 0. Now, plug in 2 times 0 plus 6 times 0 is going to be 0. Is 0 less than 24? Yes, it is. So since this makes this statement true, we got to shade below. And here, if I would have had your normal graph, my 4 quadrants, 1, 2, 3, 4, you would also be including this info here. And what this is saying earlier was that we are only graphing quadrant 1 because it's not possible in these real world situations to have negative rolls of streamers or tablecloths. So understanding only this region here that's shaded in their dark gray are solutions to this problem. So what is this saying? So let's take the solution 9, 1 right here. I could buy 9 rolls of streamers and 1 tablecloth, okay, and get my $24. Or I could buy 6 rolls of streamer and 2 tablecloths. I could buy 3 rolls of streamers and 3 tablecloths. These are different options you could and still spend your total of $24. And that's all we have for section 7.5.